Greetings. In this session, we will discuss electric vehicle charging. This is a fast-growing opportunity. About 3% of all vehicles in America are 100% electric by now. As people buy more cars, vans that are 100% electric or even hybrid, the need for electric vehicle charging infrastructure will increase. That presents a lot of business opportunities as well. So we'll discuss today several aspects that are related to electric vehicle charging. We'll start with the difference between kilowatts and kilowatt hours. These are the two units that represent very different things but are often confused with each other and used interchangeably, which they shouldn't be. Then we'll discuss charging levels. Charging levels tell us how quickly, at what speed can we charge our vehicles when we are at a charging station. Once we are at the charging station, we need a connector to connect our vehicle to the charging station, and these are of different types. This is due to historical reasons and also as the technology has evolved, but now they are converging to a single type of connector, and we'll discuss that. Another important aspect of electric vehicle charging is the cost. How much does it cost to charge an electric vehicle? And how does that compare to a gas-powered vehicle? We'll discuss that through an example. And then, can I set up an electric vehicle charging business? What's involved with that? Is it profitable? What are the risks? We'll discuss that as well. So first we discuss kilowatts and kilowatt hours. Simply, kilowatt is the rate at which energy can be transmitted. Meaning, if you have a system which is at 150 kilowatts, for example, it can transfer energy at a much higher rate than a system which is at 50 kilowatts. A bigger battery requires much higher kilowatt power level because otherwise it will take a very long time to fill it up if it can connect only with a small kilowatt power connector. Similarly, if you have a small car, we can fill it up or charge it very quickly if it has a higher kilowatt range. Kilowatt hours, on the other hand, represent the amount of energy that can be stored in the car. In other words, if you look at this diagram, small car's capacity as measured in kilowatt hours is 58, and the truck has 131 kilowatt hour capacity. The kilowatts or the power is the pipe or the conductor that can transmit electricity to both of them. And if we have a transmitter or a conductor that can transmit only 24 kilowatt power, then the small car will get charged in 2 hours versus the same 24 kilowatt conductor can charge this 131 kilowatt hours in about 5 hours. So that's the difference between kilowatts and kilowatt hours. The mileage of electric vehicles is typically measured in kilowatt hours per 100 miles. The equivalent for gas vehicles is miles per gallon of gas. So a large car like a truck, a large vehicle like a truck can typically go 100 miles in 48 kilowatt hours. So for example, if it has a 300 kilowatt hour battery, it can go 600 miles. If a small car has a 100 kilowatt hour battery, it can typically go about 300 miles in that because it will take about 30 kilowatt hours to go 100 miles in that car. When we talk about electric vehicle charging, a very important aspect is the charging level. How fast can an EV be charged? And it depends on two different things. Number one, the capacity in kilowatts the power capacity of a system in kilowatts to discharge how much current it can flow at any given time. Higher the kilowatts, faster it can charge the vehicle, or it can charge several different vehicles at the same time at a reasonable charging rate. Another aspect is the kilowatt capacity of the battery system of the vehicle itself. Each battery system is rated at certain kilowatts, and if it is higher kilowatts, it can be charged faster. So for this vehicle to be charged fast, both the conditions have to be met, meaning the electric vehicle charging system as well as the vehicle battery system both have a high kilowatt rating. Many a times electric vehicle chargers, they are connected to several different cars at the same time, and that way the kilowatts are actually distributed between different cars and the charging can slow down. Level 1 charging system is typically found at homes. It connects to a normal 110 volt outlet. It's very slow. It's legacy, but it's the cheapest one and the simplest one, and doesn't require any kind of modification in the home electrical circuits. But it charges only 3 to 5 miles per hour, meaning to fully charge a car, it will take about 60 hours. Not very efficient. And currently it can be found in places, but gradually it's being faded out. The more common system is the level 2 system, and it can be found in homes as well as public charging places. And it connects to either 110 volts or 240 volts. Both the voltages are actually found in our homes as well. And it charges 12, 14, 15 miles per hour to 80 miles per hour. And on most occasions, it's called an overnight charging. And that works very good because your vehicle can charge while you're asleep, and electricity rates are pretty low during the night. So that's a win-win situation for the utility company and yourself. However, this also still takes about 8 hours to charge the vehicle. The third level, which is the fastest charging level, is the level 3. It is also called DC fast charging, and there is a technical difference between level 1, level 2, and of course on the other hand level 3. The DC charging works at 400 volts to 900 volts, and therefore the safety precautions are different for this system, and it's mostly commercial grade. This can charge a car at about 200 miles per hour and basically fully charge the whole vehicle in about 1.5 to 2 hours. But because of the facility and the time saving, the value of that, it is charged at a higher rate. So it costs more to charge at level 3 than level 2 and level 1. Level 2 being at home, for example, it's considerably cheaper to charge your car at home rather than DC charging outside. And we'll take a look at the comparison in a later slide. Electric vehicles are charged through a cable. One end of that cable is attached to the charging source. The other end has a connector that fits into the charging port of the vehicle for the charging to start. Initially, the industry adopted a 5-pin architecture. That 5-pin architecture worked for level 2 as well. However, when fast DC charging arrived, the industry needed to add 2 extra pins at the bottom of the normal level 1 and level 2 charger. Now this enabled charging from level 1, level 2 and level 3 from a single connector. For this reason, this was called as the combined charging system design. However, Tesla went on its own way and designed its own connector. Now this was not adopted by rest of the industry, but because Tesla has so many fast DC chargers spread across America, other brands of cars were not able to take advantage of them. Gradually, because of this leverage, Tesla was able to push their own design as the industry standard. Last year, Ford and General Motors adopted Tesla's fast DC charger design, and eventually the North American charging standard is converging to the Tesla charging design. So we should expect this design to be adopted in more and more cars as we go forward. There is another charging standard which was pretty old and used mostly in Japan, but may fade away. And you can occasionally see that on Nissan Leaf cars. It's called CHAdeMO, which literally means charging on the move and is a play on the words in Japanese language, meaning sitting around and having a cup of tea. But that may not last very long, and we will typically see a Tesla charger as in an industry standard going forward. How much does it cost to charge an EV? The fuel for an electric vehicle is electricity, so the cost is entirely dependent on the price of electricity at any given time. So, for example, for a 300-mile range, we need about 120 kilowatt hours of energy in a medium-sized electric vehicles. The price of 1 kilowatt hour of energy varies from 10 cents to 14 cents typically across America in our home. So with that price, it costs around $12 to fully charge an electric vehicle at home for a 300-mile range. However, for commercial establishments, especially for level 2 and level 3, because they provide the convenience, they charge much higher charging rates. So Electrify America at 30 cents per kilowatt hour will cost about $36 to fully charge an electric vehicle for a 300-mile range. A Tesla supercharger charges the maximum amount of money for per unit of kilowatt hour, but it charges the car very fast in maybe a couple of hours. And for that value, that convenience, they charge a pretty high price for the electricity at about 45 cents. And for that, one will be set back by $54 for a 300-mile range in an electric vehicle. On the other hand, for comparison, at $4 per gallon and 25 miles per gallon for a gas car, it will cost about $48 for a gas-powered car to go 300 miles on that. Moral of the story here is it's the cheapest to charge the car, electric vehicle, at night, at home, when the electricity prices are the lowest. And if one is at a timed cost of electricity, the cost of electricity beyond 10 p.m. until 6 a.m. in the morning is the cheapest, and that's when the car needs to be charged. And some utilities actually have a special EV charging price during the night. So one should take advantage of that. As the number of electric vehicles on the roads increases, the demand for electric vehicle charging will increase. One can not only provide a service to their own residents in a community, but also run it as a commercial business and possibly make a profit on EV charging. But like any other business, EV charging has its own issues as well. For example, one needs to buy the EV charging equipment, but also prepare the site, including running a cable from the utility grid to the charging station itself. Then there's the maintenance, insurance, and physical safety of the assets. Because these systems are unmanned, the need for safety is pretty high. The success of the EV charging business depends on location. A lot of people should be able to use it at all times of the day and night for this to become a profitable business. Another aspect that one must consider is sourcing of electricity at a favorable price at all times of the day. That will help reduce the operational cost and the business will then become much more competitive as compared to others. The business can also provide value-added services to make the charging station attractive to the vehicle charging clients. For example, one can make the charging station well lit and safe. Also provide restrooms for just clients. Provide food, and that is a familiar thing from a normal gas station where gas itself may not make that much money, but the ancillary services and products that a gas station provides, like food, ice, milk, those kinds of things, they make much more money than the electricity itself in case of EV charging system. One can also provide free Wi-Fi and even phone charging. And if the possibility of scaling the system is there, that will actually make the business much more profitable in the long run. Thank you.